And when you are using simple cleaning testing method, you'll find out that you have clean either samples or instruments pretty much everywhere. But let's say in this particular spot, we seem to be coming out with instruments that still contain residues on the outside after the process.
Rising above the buzz of ultrasonic cleaners and the clanking of stainless steel are the ideas and voices that are changing an industry. You're listening to the Beyond Clean podcast, the central nexus for the people, processes, and products that are improving our sterile processing world. Each week, we speak with frontline technicians, CEOs, engineers, and entrepreneurs with a common goal: to help you fight dirty, every instrument, every time. Whether you're tuning in for education or inspiration, we're glad you did. Now turn on those washers and turn up the volume. It's time to go beyond clean.
All right, clean freaks, welcome back to the Beyond Clean podcast. My name is Bobby Parker in studio today, and my co-host Hank Balch is out getting some of that much needed rest and relaxation this week. And so we'll wish Hank the best this week. But don't you worry, we're going to pick up right where we left off here on this final episode of our season 25 podcast, the little things that make a big difference, as we've covered topics that range all over the place, from case cart casters and sterilization door gaskets through break room fridges of all things. Today, we're going to take a little bit of a deeper dive into a technical topic: ultrasonic cleaner transducers, something that you probably haven't spent a lot of time thinking about in terms of making sure that your ultrasonic cleaner is working correctly. But similar to that conversation we had around the sterilizer door gasket, the transducer is one of those pieces or components of our ultrasonic cleaner that is crucial to make sure that it's functioning the way that it should be functioning. And it's unlike the sterilizer door gasket in that it's something that you usually can't see as a visual check to see if it's failing. And so we've got a treat for you in terms of the guests that we're bringing in. We're going to be talking to Pawel de Sternberg Stojalowski in just a minute, and you're probably familiar with that name if you've been a longtime listener of the podcast. And so we'll get that introduction underway here shortly. But Pawel's background is actually in ultrasonic cleaner manufacturing. And so I'm sure that he's got a lot of insight for us today. So we always treasure all of the guests that we invite on to this podcast and try to spotlight a lot of different voices from you all, from the front lines up through CEOs and everybody in between. But sometimes we like to bring on a technical expert like Pawel to really cause us to sharpen our pencils and unearth some new things that maybe we haven't heard before. So I would encourage you to stick with us, lean forward, get out that sharp pencil to take some notes, because I imagine we're going to learn quite a bit about ultrasonic cleaners today. So hang with us and we'll be right back. I'm Bobby Parker.
And I'm Hank Balch.
From the studios of Healthcare HQ, you're listening to Beyond Clean, the global voice of sterile processing.
All right, clean freaks, welcome back to the studio. Joining us now in studio is Pawel de Sternberg Stojalowski, the chief engineer and scientist at Aseptium Limited. Pawel, it's great to talk to you again here on the show.
Oh, it's my pleasure entirely. It's been great to talk to you every time we've sat down to record an interview. And this time we are talking about one of my true passions, ultrasonics. So I can't wait for the questions.
That's great. That's great. And we keep saying welcome back and good to see you again. For those of you who have been a longtime listener here at Beyond Clean, you may remember some of Pawel's previous episodes on Beyond Clean talking about decontamination and the testing devices for decontamination. I mean, how can you forget a voice and a name like Pawel de Sternberg Stojalowski, right? So yeah, I would encourage you either pause the episode now or finish this one and go back and check out some of those great interviews that we've done in the past with Pawel. But yeah, Pawel, when we were talking about Yeah, when we were talking about the little things that make a big difference, and particularly thinking about this ultrasonic conversation, we knew that we had to get you on the show to talk about this because of your big background in ultrasonic cleaning. And so for those of you who maybe don't know you terribly well or need a little bit of an introduction to your background, can you walk us through a little bit of what your career relationship to this ultrasonic cleaning conversation has been like?
No, absolutely. I was actually introduced to ultrasonics when I started my journey into decontamination, starting with MediSafe International in the UK, and obviously a company that manufactured and still manufactures now under a different name, a range of ultrasonic washers. And that's how I got exposed to the whole cleaning technology using this method. Having to develop innovations within that field, I had to deepen my knowledge as well to make sure that we make the best of it.
That's awesome. That's great. So thinking about ultrasonic cleaning then and how that's been such a big part of your kind of decontamination journey, it seems a little silly maybe to be defining what is ultrasonic cleaning for the audience that's going to be listening to this podcast. But let's start at the very top. What are these ultrasonic cleaning machines, and maybe a basic definition and description of what it is that we're trying to do with these ultrasonic cleaners, and particularly these ultrasonic transducers that we're talking about?
Perfect. So ultrasonic cleaners are washing machines that use ultrasonics as the main mechanical form of delivering energy that cleans the instruments. And how it happens is ultrasonic tanks hold the instruments, and those instruments get submerged into water, and the ultrasonic transducers that are bonded to the tanks are emitting ultrasonic energy into that water. And inside of this water, we create this way a phenomenon called cavitation. Cavitation is when little bubbles that are created by those ultrasonic waves are created and collapse. And when they implode, they release shockwaves, and shockwaves are fantastic to watch, and they are super efficient in removing contamination and debris from instruments. So that's the basic idea. And when we are talking about ultrasonics, we have to talk about what the ultrasonic actually means. We are talking about the frequencies of sound that are higher than what a human ear can hear. So that is why we don't actually hear the actual ultrasonics working when the machines are on, but all we can hear is a hum. Those are the waves that are bouncing back and forwards, and they multiply and change the frequencies. So we can actually hear the hiss, that's so characteristic to those washers. But what cleans is not the sound. What cleans is the cavitation, bubbles, imploding and releasing those shock waves. And one of the reasons why we are using this for surgical instruments is we have a lot of difficult to clean features in those instruments. Narrow gaps, crevices, we have joints with tiny, tiny spaces that water penetrates, and ultrasonic energy can create bubbles inside of those. Therefore, it means that the penetration of the cleaning action is much greater than in your standard deluge or impingement washers.
Okay, very good. Well, yeah, you're dropping some knowledge on us already. I have always wondered why it is our ultrasonic cleaners don't sound like a freight train if we're trying to get this almost kind of violent cavitation cleaning process going on in the solution, and that's done through sound waves. Why does it sound so quiet? So I appreciate you dropping that knowledge on us and talking about cavitation. And you also have made the transition as we work from definitions into the rest of this interview easy, because we're talking today about little things that make a big difference, right? And as we think about the big difference that ultrasonic cleaners make, you mentioned some instruments that maybe have certain cracks and crevices that are difficult to clean. Just in your experience working with ultrasonic cleaners and working through the process of getting FDA clearance for cleaning certain types of instruments, Could you maybe paint a thumbnail for us of how important you think ultrasonic cleaning is for patient safety and for instrument cleanliness?
So there is, as I mentioned briefly, a group of instruments that are super difficult to clean. They have elements of their design. Think of robotic instruments, for example, as something to have a picture in the mind while thinking of those tiny little details that you have in those instruments that normally would not be cleaned if you just subjected that to a jet of water from one direction. That's what happens in a washer disinfector, for example. So you have to have a different mean of delivering that mechanical cleaning power into those elements, and that's when ultrasonics come into play, because those bubbles are formed within the entire volume of the fluid that you submerge your instruments in. And if you push the liquid through the instruments, or you allow the liquid to fill the instruments as well, they are created inside as well, which is exactly what we are talking about.
Right. So you can really get in there on those instruments. So I'm guessing a pretty massive difference for patient safety, particularly on those complex instruments. And
I would say that for some instruments, you simply must have this done, and there is no other way to clean them effectively in a reasonably short time.
Sure. Yeah, and I think most of our listeners are probably very familiar with ultrasonic cleaners, right? They've heard that familiar hissing and buzzing noise in the corner of their decontamination room. But when they saw the title of this episode and heard us talking about ultrasound transducers, that term may not be quite as familiar to them. You know, maybe they studied their CRCST, they know all about cavitation. But what is this about ultrasound or ultrasonic transducers we're talking about, and kind of the anatomy and the parts of our ultrasonic cleaner?
No problem. So ultrasonic transducers are the elements that are bonded to the tanks that actually emit the ultrasonic waves into the tank. Ultrasonic transducer is a very interesting piece of kit. It's a very simple device in its operation, but how it's done is the clever bit. So imagine the ultrasonic transducer works in the same way as your speaker. Right? So there is an element that makes it move, creating pressure wave. The problem is that our speakers in your home audio or even in your earphones, they emit sound that we can hear. That's the whole point, right? Ultrasonic transducers, as the name says, use ultrasonic frequencies. So the sound that is way higher, the sound frequency that is way higher that we can hear. And what is the transducer made of? There is a mass usually made of hard materials like titanium, stainless steel, or aluminum, and it's locked to a piezoelectric material. Piezoelectric material is a material that expands when it's subject to electrical voltage. So imagine that unlike your tiny little millivolt or single volt signals around your speakers, over here we are talking about voltages that are in excess of 70, 80, sometimes even 100 volts. And they are sent to those transducers as a wave. So they go up and down, up and down. And typically we use from 28 kilohertz to a couple of megahertz frequencies here. So those waves are super high frequency, and that's how quickly the transducer contracts and expands. Doing that 40,000 times a second gives you the 40 kilohertz transducer.
Now, I'm no scientist, Pawel, but I'm going to do my best to try to summarize this in one go, so you can let me know if I've got it. So we've got a generator that produces high voltage electricity that is sending this electrical current to these transducers that are fixed to sometimes the outside of the tank, and they're what are converting that electrical signal into some kind of mechanical sound wave into the cleaning solution to create the cavitation. Is that what we're talking about?
Exactly. So the piezoelectric element of the transducer contracts and expands, and it's pushing that mass that is attached to. So it then that vibration is transferred to the side of the bottom of the tank, typically. But there is also another class of transducers, which are rod transducers that work on exactly the same basis, but instead of being bonded onto the surface of the external surface of the tank, they are actually inserted into the tank, and the piezoelectric stack. So there's a stack of typically piezoelectric discs made of usually PZT material, if that's not too much information. And once they are subject to this alternating wave electrical energy, they contract and expand, sending the waves directly inside of the tank.
Okay. So we're about halfway through the conversation here already, Pawel, and we're just getting through definitions because there's a lot to unpack here. So I appreciate that very thorough introduction to our transducers. You've mentioned the bonded transducers on the outside of the tank, the rod transducers inside, and functionally they're trying to accomplish the same thing, that ultrasound energy to get the cavitation rolling. Can you maybe give us some of the considerations for these different types of transducers? I mean, are they all created equal, or some maybe better than others at accomplishing certain things? Why would manufacturers pick different types of these transducers?
So, as you mentioned, the primary goal is to deliver ultrasonic waves into the liquid, right? Both types of transducers do it very well, but there are considerations to be taken. When you use what we call horn transducers that you bond onto the outside of the tanks, they have to be bonded. That's the problem. But you have to find a method to actually attach them in such a way that the bonding agent or the glue that you are using is not going to impede or soften the vibrations. That's one. Second, because they are receiving a lot of energy, they heat up. So you don't want glue also to stop conducting the energy because of heat. And lastly, the glue needs to stay there for a long time. And we know of the situations where the transducers simply fall off the tanks and they have to be rebonded. And that's a problematic situation because it takes a lot of time. It's definitely doable, and I've done it a number of times, but it's just something that you have to be mindful of. And certainly when you have a situation where a transducer falls off a tank, you have to somehow find that it actually happened, because on the outside of the machine you will not see anything. But if you are going to do the proper testing of your tank, you'll find out that there may be a dead spot there that is not being cleaned. And one of the reasons it might be that the transducer that should be sitting underneath has fallen off. The same thing with the rod transducers, because they are typically long pieces of heavy metal. They basically hang on the walls of your tank, and because that is a piece of heavy metal, it also needs to be attached in such a way that does not impede the transmission of the ultrasonic. So again, that's another consideration to be taken care of.
Sure. So maybe some pros and cons associated with each. One of the things that you mentioned that I think is going to help connect this to the daily practice in sterile processing is, that discovery that maybe one of our transducers isn't working anymore and we've got a dead spot in our ultrasonic cleaner. Could you walk us through kind of the typical way a sterile processing department might discover that and why it's so important to discover that one of your transducers isn't working the way that it should?
So one of the ways, and this is the interesting thing, we mentioned that the machines emit this sort of hissing noise. If that for some reason changes in terms of its loudness or its frequency slightly, that may be an indication that there is something wrong with the transducers, but it may also indicate that there's something wrong with the water level in the tank. So that's one thing. Second thing, and this is the no-brainer here, if you do proper testing of using either indicators or special ultrasonic energy meters you can actually map the volume of your tank to find out whether you don't have a spot where your energy is significantly lower. And when you are using simple cleaning testing method, you'll find out that you have clean either samples or instruments pretty much everywhere. But let's say in this particular spot, we seem to be coming out with instruments that still contain residues on the outside after the process.
Yeah, it's really interesting to think about that. When I first started as a sterile processing leader, I was always a bit skeptical of some of the tests that were being sold, and particularly the quantity of recommended tests being sold. And ultrasonic cleaners were one of those that made me kind of roll my eyes a little bit at the recommendation for the number of these tests, these cavitation tests that they were recommending we put into the tank. You know, sometimes particular manufacturer would want us to put 5 tests in one cycle. And I was just adding up the cost of what that was and maybe thought that was a bit overkill and thinking through that this is just a way to sell more tests. But ultimately what that motivation came down to is, like you mentioned, ultrasonic cleaners, depending on what goes wrong with them, they might not fail in every place in the same way all at the same time. You might have one corner of your tank that isn't functioning because that one transducer is bad, but the rest of it's working well. And so without kind of mapping out those tests across your chamber, you might not discover that you've got some weak spots and some hot spots. So I think that's really fascinating. From a design perspective, Pawel, are there better configurations than others in terms of limiting those hot spots and cold spots in the cleaning solution? Like, are there better designs than others, even for ones that are functioning the way that they're supposed to?
So typically when you have bonded transducers, you have an array of them bonded to the bottom of the sides of the tank in such a way that they try to even physically cover the entire area more or less evenly. With the rod transducers, it's a slightly different conundrum because the rod transducer is emitting directly inside of the fluid. So it's through the process of design and the shape of your cleaning chamber, you can actually alter the spread of the ultrasonic energy within that volume. Both technologies are equally effective if they are properly designed.
Yeah, properly designed and maintained and used according to their IFU and all of those things. Before we close this conversation around ultrasonic cleaners, I hesitate to move on without just discussing a little bit of the sterile processing workflow considerations for ultrasonics. You know, you mentioned that these devices are intended for removing debris, but could you give us a snapshot of maybe where we should be using this ultrasonic cleaner in our workflow? Is this the first thing that our instrument should be going into while they're heavily soiled? Does it come in last? What's your take on that?
So my take on this is that you have to think what type of cleaner you have. If this is a simple bath that cleans at cold water, this is something that you would be using as one of your pre-cleaning processes, so before the instruments actually go to a washer disinfector. However, there exist ultrasonic washer disinfectors that provide the solution in one process, and that's when ultrasonics will be used most efficiently somewhere in the process, and it's definitely before you use your disinfection step.
Right. Yeah, it's part of the cleaning action. And Pawel, I just want to address the elephant in the room just based on your accent that there's an international component to this as well, right? And so a lot in the American standards and the way that we do a lot of manual processing, you know, you'll have those instruments come through a pre-rinse at the sink, pre-wash at the sink, then go through our ultrasonic cleaners, get another rinse, go into the washer disinfector. But in Europe and in other places, it seems like there's a lot more of the automated cleaning that goes on that incorporates that ultrasonic directly into the automated cleaning process.
Absolutely. Right? And this is the way that I would definitely advocate for a simple reason. If you have an automated process, it's typically time sensitive, and your automated machine is going to measure that time for you. So if you have a process that you have proven it works time and time again, it is going to be executed in the same way, provided your machine is in order. If you're doing everything manually, there is that element of, have I actually used it for 10 minutes, 15 minutes, 20 minutes? Maybe different instruments require different timing. This is down to what you are actually cleaning, what's your specialization. If you have just a mass of different types of instruments, you have to sort of figure out what goes through what process, and that's where your experience kicks in.
That's really insightful and helpful. And it's my hope and expectation that we're going to see more automation, particularly coming here to the States over the years. For whatever reason, we tend to stay about 10 years behind the technology that takes place overseas. I'm not sure what that is, but yeah, I'm sure more of that is coming. Pawel, thank you for that really deep dive on ultrasound transducers. This is the last episode that's going to be released in this season of the podcast on the little things that make a big difference. But in each of these episodes along the way, we've asked our guests if there's one other random topic that they would want to throw out there as a little thing that makes a big difference for sterile processing. And so whether related to ultrasonic transducers or not, what's one other little thing in sterile processing that you think is crucial for patient safety?
Because apart from developing solutions here in the labs at the Septium, we are on a daily basis using washing systems and validating different processes. I find that testing is the key element of knowing where you are. Without testing, you are not able to say whether things are definitely there or not. So I would say test as much as you can, because that gives you confidence that everything that you are putting your instruments through works properly. And that's my little hint on how to improve your daily routine.
That's a good word. And we'll use this as your reminder to go and check out Pawel's other conversations, because he's got a great interview on washer disinfector tests and how those are developed and used in a department. And yeah, just the importance of challenging your cleaning processes. So Pawel, great interview today. Thank you again for coming on the show and educating us a little bit on the deep dive of the anatomy of these hissing boxes we've got in our decontamination.
That was absolutely wonderful. I'm always happy to share what I know about decontamination. So if there are any questions following the interview, just direct them to me and I'll do my absolute best to answer them. And yeah, if there are any other subjects you want my opinion on, I'll be here.
Yeah, excellent. Well, great interview. That was Pawel de Sternberg Stojalowski, Chief Engineer and Scientist at Aseptium Limited. It was good to talk to Pawel again on the show today. If you haven't had the chance to meet Pawel either through a trade show or online, he's a joy to be around. Not only is he a longtime friend of the show, but just a general nice guy. And we love talking to folks like Pawel who have some technical experience in the field. You know, it's valuable for us to think about ultrasonic transducers and cleaners and the perspective that we experience them as users, but sometimes it's a little bit nice to scratch that curiosity and itch to go a little bit deeper and talk about the manufacturing side of this as well. So I hope that deep dive interview gave you some value as you think about the reasons why you have to test your equipment the way that you do and why you have to follow all of the recommendations in your user guide about degassing and all the things that come along with running an ultrasonic cleaner and the preventative maintenance that goes along with it. And now maybe you'll have a story next time you hear your service technician cussing about having to rebond a transducer of why that's a pain in the neck. So this is going to wrap up our season on the little things that make a big difference. I feel like we've been all over the place this season, from case guard casters through break room fridges and now to the technical side of ultrasound transducers. And so I hope that this season has been useful and enlightening to you about some of the little things that are easy to forget about, but make all the difference for our patients. And ultimately, that's why we do it, right? We want to pay attention to the small things because we care about patients having a good experience in surgery, having that good outcome. And so we do our job with every instrument every time. So with that, we're going to go ahead and wrap. If you have some more thoughts about ultrasonic cleaners or transducers that you'd like to share with us, we'd love to hear from you either in the comment section of wherever you find this podcast, or if you want to write to us, you can reach us at info@beyondclean.net. And we look forward to talking to you next season after we have a brief break here where we go back and revisit some of our best plays from the podcast. And so we'll say until we talk to you next time, keep fighting dirty.
Thank you for listening to this week's episode of Beyond Clean. As a reminder, you can help support us by subscribing to Beyond Clean on your favorite podcast app, or by downloading the smartphone app on iPhone or Android. Simply search for Beyond Clean in the App Store or Google Play. The best thing about downloading the smartphone app is that you can access bonus content for certain episodes and view episodes in certain categories, like articles on the go and vendor spotlights. Are you following us on LinkedIn or Facebook yet? If you are and you love an episode or post, then let your social network know about it. Like, comment, or share our posts along with your thoughts and keep the conversation going. If you have any topics or guests that you would like to recommend for a future episode, just send us an email to info@beyondclean.net. We look forward to hearing from you.